All right, we're back. We're on page 51 of math analysis, and we are going to try to graph a cotangent function. We'll probably do one in this video and one in the next video, and then be on the next page. So let's see if we can do it. So basically everything's the same, gathering information as it was for tangent, which is really similar to what it is for sine and cosine, but the period is pi divided by b, not 2 pi. So pi divided by b in this case is going to be really gross. Pi divided by, what's going on? Okay, 3 pi over 5, which is going to be 5/3. That's not great. And the increment is going to be 1/4 of that. So that's going to be 5/12. Also not great. But then it looks like the starting point is also terrible. So we're off and running here. So I take this and I mentally move it over. So I get 4 pi over 7 times 5 is 20 pi over 7. Divided by 3 pi is 20 over 21. So great. So x, oh, look at me writing with a highlighter. X equals 20 over 21. All right. So 21 is 3 times 7, and 12 is 3 times 4. So it looks like I'm using 84 as my common denominator. So this will be 80 over 84. And then this will be 735 over 84. Okay, so, but because of the way it works, this isn't like as bad as it could be because we're going to be labeling every other thing. So we'll be adding 70 over 84. Because we're skipping, we're going one box per increment, but we're only labeling every other increment. So like, it's pretty terrible, but it's not as terrible as it could otherwise have been, I guess. I don't know. Trying to find the silver lining here, people. So y is 12, and then I can go up 3 to 15. I can go down 3 to 9, and this I think I can space out well. So let's see. It's going to be I don't know, 15, 12, and 9. And then I think I'm going to move that down 1. So let's see. So that would give me 1, 2, 3, 4 above, and then 2, 3. Whatever. I mean, I moved it. There was no reason to. All right. So, but actually, I'm going to move it back up so that I can get to 0 because I think I can do that. So that'll be 6, 3, 0. All right, so 0 is down here. I'm gonna put in an x-axis. It's like you really gotta nail like the first point and the last point when you want the program to just like create a line for you. That's the key. When you're drawing, if you're ever drawing on a whiteboard and you need to draw a line through 2 points, first draw the line, then put the points. That's like the move. Otherwise, you have to deal with like the fact that it turns out, can't really draw a line through 2 points because it's a lot harder than you would think. All right, so 80 over 84 going in the middle. So where's the middle of this, we think? I'm thinking here. 80 over 84. Okay, and now what are we doing? We're going to go 1, skip. Every box is an increment, but we're going to skip and then add 70. So going to be here to 1, so it's going to be 150. Gosh, this is great. 220, 290. This is nuts. These are so big. 360. It's our old friend. And 430, I think. Okay. Then we got to go the other way, which is like not really harder, but for some reason a little harder. 10, negative 60. And then you just like, did I make a mistake? Probably. Obviously not intentionally. Negative 190 over 84. We could use a calculator to like generate the numerators, I guess. Like we could try to do negative 260 plus 70n, and then let n be from like 0 to whatever, and see if it generates the numerators, which would definitely check. Or you can just like really quickly look. 77, oh, no, I messed it up. I definitely messed it up. Cool, cool. All right, so let me at least fix those. So this will be two, it's like at some point I got confused and started doing 60s. When did that happen though? I guess right there, that's weird. 270. Okay. So it's 70, 70, 70, 70, 70, 70, 70, 70, 70. I think it worked. I don't know. All right. So let's see. I'm going to dot in my sinusoidal axis, which is not a sinusoidal axis, but is helpful. So like keep in mind, the whole graph that we're really interested in is happening way up here. All that x-axis stuff is just get the independent variable on. And then, all right, I'm gonna highlight the start just so we can keep track of it. And what do you do at the start of a cotangent graph? So the range, all reals, let's just do that. Y is an element of the reals. All right, so cotangent graph goes asymptote, high, middle, low, asymptote. Weird, so the first thing we're gonna do is an asymptote. So I'm gonna put it over here again and then try to like copy and paste it. You gotta avoid things though as you're putting the one that you're gonna like duplicate to be. Okay, here we go. So at the starting point, there is an asymptote, which I find very dissatisfying. So we're gonna go high, middle, low, and another asymptote. Then we're gonna go high, middle, low, and another asymptote. If it wasn't for how annoying all of the units were, this would not be taking so long. So this will go going backwards, asymptote, low, middle, high, asymptote, low, middle, high, asymptote, and then low, middle, high, so we don't get another one there. Okay, so it's asymptote. Then you go over one, you're at high, middle, low, asymptote, high, middle, low, asymptote, high, middle, low, asymptote. Then we go the other way, low, middle, high, asymptote. This is because we're going backwards. High, asymptote, low, middle, high. Good grief. All right, now we got to try to draw our curve. So the curve, just again, don't obsess over getting to the asymptote too quickly, and your curve will look pretty good. I think that looks pretty good. Here we go. But I'm doing that thing again where I'm trying to keep my hand off the iPad, which I find helps a lot. Lets me pivot more easily, I guess. Also, one shot on these. Woo! Got close to the asymptote there. There we go. That's good looking. All right, asymptotes. Always at the starting point. The asymptotes and domain for cotangent are actually a little easier to do. So the first one, starting point, which was 80 over 84, plus the period, which is 5/3, which is like, I don't even know. What is that? 5/3 in 84ths? I don't want to work that out. 28 times, whatever, 28 times 5, 500. 500. 28 times 140. 140. Add 140. Yeah, it worked. Cool. All right. So plus, I'm actually just going to write 5/3 n, where n is an element of the integers. That's 1. And then our domain is everything except that. X is an element of the reals. X is not 80 over 84. Plus 5/3 n, where n is an element of the integers. All right, so I think that looks good. I mean, I'm gonna go check it on the calculator because I feel like it's irresponsible to not check, but I'm feeling pretty good about it. So I'm gonna redefine f of x to be 3 cotan of 3 pi over 5x minus 4 pi over 7. plus 12. All right, so I think the f of 80 over 84 should be undefined. And it is, that's good. So let's see, if I add 35, well, what if I actually just do this? Here, watch this. Let's add 35 up here. And it should give me the high point. And then if I add 35 again, it should give me the middle point, which it does. If I add 35 again, whoops, plus 35, it gives me the low point. Nice. And if I ask for the domain of f of x, where x is the variable, so what is happening here? Let me expand this. I get that. Let me add 5/3. So 20 over 21, that's the one that we got that. What is this other one? I don't know what this is. Let me expand it. Whew. Let me add 5/3. Let me add 5/3. What are you? I do not know. I don't know why it's spitting this out. Did it give me a warning? Is this like some extraneous domain restriction? It doesn't really seem to be. Let me do this. Let me do sequence. So the second one is the one that we found. Let me just change this to n. Let's do n. I don't know, like 3 to 10. So what are these? Let me do f of this 12. I don't know what it's doing there. That's extraneous, and it doesn't give you any kind of warning. So watch out for that, I guess. But that's interesting. I've never run into that before. It gave me an extraneous domain for a cotangent, and I don't really know why. So it gave me 12. It gave me where, it seems to have given me where cosine is equal to 0. It's as if somehow it's dealing with tangent and cotangent at the same time. I don't really know. That's a mystery. That's kind of neat. So maybe take a look at that, see if you can figure out what's going on. Those are definitely not places that the function is undefined. So you always got to check, you know, like don't just blindly believe your calculator, is I guess what we learned there. But anyway, I think we did a good job. So I'm gonna come back in the next video, do the next one, and I will see you there.